in Pharmaceuticals in association with Higher Secondary Principals Forum.
Hello learners, welcome to yet another class of mathematics. I am here again, teacher Archana Shetye from Don Bosco High Secondary School, Panaji, to discuss one more chapter from mathematics syllabus of 12th standard. Today's chapter's name is Matrices. I would like to remind you learners, this chapter has 6 marks weightage in Goa board mathematics question paper for science as well as commerce stream. This concept is very crucial for JEE aspirants also. So learners, today we will explore the entire world of matrices without delay. Here we will able to answer different questions like what do you understand by matrices? How does matrices looks like? Why we study matrices? What are the different protocols or procedures we use when we add, subtract, multiply different matrices? So students, today's chapter is matrices. Let us see history of matrices. Matrix is arrangement of numbers which was introduced in 1850 by James Joseph Sylvester. Later on, Sir Arthur also introduced matrix multiplication, and his contribution is very crucial in field of matrices. Now let us begin with the chapter matrix. Now over here, one thing you people need to remember, matrix is singular form and matrices is plural form. So here, since we look at the one matrix, here we say matrix representation. A matrix is a rectangular array of numbers, real or complex, arranged in the form of rows and columns enclosed in a bracket. Now here, if you look at this diagram, you will able to understand here I denote this matrix with capital letter A, and here you can see these brackets. This bracket can be box bracket, these brackets also can be curly bracket, or this also can be, if you see this diagram, we denote it with capital letter A and we denote this matrix in this form. Now here if you see, this horizontal line signifies number of columns. Here you can see here, this is first column, second column, third column, dot dot dot, we will have here n number of columns. Similar way, if you look at these vertical lines, here these we denote this matrix as capital A and we write matrix in this form. Students from computer science, they will know this matrix concept very well. Why? Because they have very close relation with concept called rectangular array. Now let us look at the different terms what we use in this matrix representation. Now here if you see this horizontal entries, what you can see, these horizontal entries are called as rows. These vertical entries you can see are called as columns. Now like this, if you see, you can see here there are n number of columns and m number of rows. So over here if you see, this A11 represent the first element and the position of this element is first row and first column. Similar way, when you proceed here, if you look at the position, if you look at the place of this particular entry signifies first row and second column, and that's why it is A1, 2. And then when we proceed further horizontally, we can see here it is A1n. That means here you consider first row itself but n number of column. Let us go to the second row. When you talk about second row, this entry is A21. Now what this 2-1 signifies? This 2-1 signifies it is second row and first column. Similar way, when you go further, A22, what does it signify? It signifies it is second row and second column. And similar way, here we have all these entries, and this suffix numbers shows the position of that particular entry. Now when we talk about entries of this particular matrix, you can have real numbers or complex numbers, or you can have different functions. Different functions which includes trigonometric functions, modulus functions, logarithmic functions, and so on. Now if you look at the third node, the matrix denoted by A, B or C. Whatever letter you take, see that that letter is supposed to be capital when you denote any matrix. And the elements what you denote which are inside this particular bracket, these are denoted by small letters A, B, C, D, any letter from 26 alphabets. Now let's proceed further. Order of matrix. Now this is very crucial definition. Now what do you understand by order of matrix? If you look at this last entry, what you can see here, that is AMN. So MN represent M number of rows and N number of columns. So over here, what do you understand by order of matrix? It is total number of rows into total number of columns. So for this particular matrix, in general when we talk, the order of this general matrix is M cross N, or you can say it is M into N. Okay, so let's proceed further. Now these are the different examples of matrices. Now over here when you look at this first example, you can see here there are 2 rows. So here you can see 2 in the place of M, and since there are 3 columns, we have 3 in place of N. So what is the order of this matrix? It is 2 into 3 or 2 cross 3. So same way, if you look at this positions, if you look at this, what is the position of these 2? This is A11. What is the position of this 1? It is nothing but A12 and so on. Now if you look at this 3, now I want to find out the position of this 3. The position of this 3 I can get, look at this. Here I am at second row, so I say A2, and I am at third column. So here I say 3. So it is, look at this, A23. Now look at this another matrix here. Now here I denoted as A, here I denoted as B. Now look at this. Now here how many rows you have? 1, 2, 3. And how many columns you have? Here only 1 column. So here I say 3 cross 1. So since we have 3 number of rows and 1 number of column, I get it here as 3 cross 1. Now look at the corresponding entries here. This is the place of this 3. The 3 is at what place? B11. Now 2 is at what place? B21. Now 0 is at what place? B31. So 31 signifies third row and first column. Okay, look at the third example. Now this matrix is of what order? 3 cross 2. Why 3 cross 2? Because over here you have 3 rows and 2 columns. Look at the positions of those elements. Now here, since I am talking about matrix C, here you have C11 at, here see, it's 6 is at C11. Now here 3, now 3 is at what position? It is at C22 position. So here if you look at this, the order is 3 cross 3. Now here look at the fourth matrix. Now you can see here only one row, but how many columns you have? 1, 2, 3. So what is the order of this matrix? It is 1 cross 3. So over here you can see E11 is the first entry, E21 is the second entry, that's 0, E13 that is the third entry, that is -1, and the order of this matrix is 1 cross 3. Now let us look at the problems. Now here let us take first problem, construct a matrix of order 2 by 2. Here I need to construct matrix of 2 by 2, and here see matrix generator is given to me, that is Aij equals I square minus j plus 1. Now over here see I explained you all different positions of these elements. Now over here see I need to get 2 by 2 matrix. So the number of columns supposed to be 2 and number of rows supposed to be 2. Look at this. This is supposed to be the structure of this matrix. So over here A11. So at A11 position, look at this. Here see, using this matrix generator, I am getting A11 equals, wherever there is I, we have 1, wherever there is j, we substitute 1. So we get over here as 1 square minus 1 plus 1 equals 1. Same way we get A12. So in place of I we put 1, in place of 2 we put j, and we get 1 square minus 2 plus 1, the answer comes to 0, and we get here, that's, here see A21 position. So over here I get 2 square minus 1 plus 1, so I get it as 4, and A22 I am getting it as 3 by substituting I is equal to 2 and j is equal to 2 in this matrix generator. And at the end what I do is I substitute in the position here of the elements, and I get my matrix of order 2 by 2. So this is how we construct matrix using this matrix generator. So in this kind of problem, two things are important. First, what order is given and what is your matrix generator. Now here we have some practice problems, so you can pause and you can take these problems and you can solve it for your practice. Now here again I say here the order is important, so order is given 3 into 2 and the matrix generator is given. Same way second problem is in the same form, third problem also is in the same form. Now let us go to the first matrix representation. Now over here you people need to know certain things, that is, if you look at this, the diagonal, you can see this diagonal over here, the corresponding entries in this diagonal you can see here. If you look at the pattern, you can see I is equal to j. So you have A11, then you have A22, then the third can be A33, then it can be A44, and when you proceed like this you will get AM. So over here when you talk about the diagonal, and if you have the square matrix, what you will get? Square matrix in the sense the number of columns will be equal to number of rows. In common language I could say the matrix will look like square. Okay, so here as I told you all, this A11, A12 represent entries, and also I explained you all, you can put different numbers, it can be real numbers, complex numbers, it can be functions including logarithmic function, trigonometric functions in the place of elements. Now let us start with type of matrices. Now over here when we talk about types, The first type, that is row matrix. When you look at the word itself, you will understand here the matrix having only one row is called row matrix. And if you look at this, you can say A equals Aij, and if you look at the order here, you get it as, here see, only one row. So you have m is equal to 1, but you can have n number of columns. So you have here n. So when you talk about order of this row matrix, we always have 1 cross n. Now look at the examples. A equals here 5, 2, 0. These are the elements and it has only one row but 3 number of columns. So you get over here order as 1 cross 3. Now look at the second example. B equals, here you have 2 columns but only one row. So here see, at m's place you have 1. So it is 1 cross 2 and so on. Now here see, if you look at this matrix C, it has only one element but yet it is your row matrix. Why? It satisfies this particular equation, or you can say this particular condition, that is 1 cross 1. So number of rows equal to 1. So this also example you can take under row matrix. Then we talk about column matrix. A matrix having only one column is called as column matrix. So you can see over here, you can have m number of rows but you will have only one column. Look at the examples. Here see, you can see only one column you have, but here you have how many rows? 3 rows. So that's why the order is 3 cross 1. Look at the second example. You have 2 rows but only one column. So the order is 2 cross 1. And similar way you can see C equals, here see, the matrix containing only one element. So this matrix is also your column matrix. Let's go to the third one, zero matrix. It is also known as null matrix. Now what does it mean? A matrix in which all the elements are 0 and is denoted by capital letter O. Now over here see, here I take, here see all the entries what I have considered over here, all the entries are 0. Now you can see here this matrix is look like here square. So you can see, that's why I called it as square matrix, and over here you can see the order is 2 by 2, or you can say 2 cross 2. Here when we talk about this, this is your row matrix, but the entries if you see 0, 0, and that's why it comes under zero matrix. If you look at this matrix, again the order is 3 cross 3 and the entries are 0. Now let us explore the next type of matrix which is very important, that is square matrix. A matrix in which the number of rows is equal to number of columns. Very important definition, a matrix which is having number of rows equal to number of columns. Now look at this. When you look at this matrix, you can easily make out it is square matrix. Why? Because the shape of this matrix is like a square, and to add more to it, we say here the order is 2 cross 2, or you can say the order is 2. We never say 2 cross 2, but we say order is 2. It is understood a square matrix of order 2 is nothing but here the rows equal to columns. So over here again, here B equal to 4, again you can see it is also square matrix. Here C, the matrix C, if you see again there are 3 rows and 3 columns, so hence it is part of square matrix. Let us proceed further. Diagonal matrix. Just now I explained you all which are the diagonal elements. So over here we talk about diagonal matrix, a square matrix in which all the non-diagonal elements are equal to 0. So over here if you understand this, it is very simple. It is here you take A, matrix A, Aij, here see, always I consider as M cross M or a matrix of order M. Why? Because if you consider your diagonal matrix, that matrix has to be square matrix, okay. So that's why the order is M cross N or the order is M. Now look at this here, what is given? Aij is not equal to 0 when I is equal to j. So I explain your diagonal elements where I is equal to j you get along with the diagonal of the matrix. So you say here Aij is not equal to 0 when I is equal to j, and Aij is equal to 0 when I is not equal to j. Look at the example. Now here you can see this is the diagonal what you consider. Now you will say, teacher, this is diagonal, then this is also diagonal. But here remember we consider only this diagonal which starts from left and goes to right, okay. So this is called as principal diagonal and this is called as minor diagonal, and always we consider principal minor diagonal as diagonal of matrix. So here you can see A11 you have as a number, A22 there is number, but if you consider A12 it's 0, A21 it is 0. Same way if you consider here the square matrix of order 3, if you look at this, A11 as A, A22 as B, A33 as C, but all non-diagonal elements, that is here A12, A13 and this similar way A21, and here you can see here this as well as these two, you see these are 0 entries. Let us proceed further. Scalar matrix. Now to say the given matrix is scalar matrix, first of all I need to have it as diagonal matrix. Now when you say it is diagonal matrix, when it is square matrix. So remember, when you talk about scalar matrix, it's supposed to be diagonal matrix, and when we talk about diagonal matrix, it has to be square matrix. So over here a diagonal matrix in which all diagonal elements are constant and equal. This is very important. All the elements along with the diagonal, if you see, these are equal and this is a constant number. Now here see the same definition goes. Here see, I said here Aij is not equal to 0. So not equal to 0 means any number, right? So here I say scalar matrix Aij is equal to k, one particular number. Okay, and here see, you can see I is equal to j. What does it signify? It is your diagonal matrix. Here you can see diagonal elements A11 and A22. Now over here when you look at this matrix of order 3, again along with the principal diagonal all the entries are same and non-diagonal entries are 0, and that's why it is called as scalar matrix. Let us proceed further. Unit matrix, or it is also called as identity matrix. Now what does it mean? A scalar matrix in which all the diagonal elements equal to unity. What does it mean? Unity means 1. The diagonal entry is supposed to be 1. You can see along with the diagonal what entries you have? 1. Here you can see along with the diagonal what entries you have? 1. And non-diagonal elements are 0. Okay, so this is a square matrix of order 2 which is diagonal matrix, and that's why here it is unit matrix. Why? Because along with the diagonal you have the entries as 1. Now look at this here. It is a square matrix, it is diagonal matrix, it is scalar matrix, and top of it, since the entries are 1, you have it as identity matrix or unit matrix. Let us proceed further. After studying all the different types of square matrix, we go to another form of matrix, that is rectangular matrix. Now over here when you talk about rectangular matrix, look at this. The form of matrix itself tells you the definition, the rectangular form. The matrix is in the form of rectangle. Now when it happens, when the matrix having number of rows which are not equal to number of columns. Look at this now, different examples here. Here number of rows equal to 2, number of columns equal to 3. Same way here, second example, number of rows equal to 3, number of columns equal to 2, so the order is 3 cross 2. Here again, this is your row matrix, and again you can see the order 1 cross 3. Same way I can take column matrix also, and so on. Now let's proceed further. Triangular matrix. Now here we have two types of this matrix. Now over here it is upper triangular matrix and second one is lower triangular matrix. What does it mean? A square matrix in which all the elements below the diagonal are 0. Now over here, see, if you see here, so this is the diagonal, so this is a benchmark you can say. So above this diagonal and including this diagonal, all the elements are non-zero. But below this diagonal, all the entries are 0. You can see over here, it is written in this form, Aij is equal to 0 when I is less than equal to j. Now here you can see I is less than equal to, you can see I is 1, j is 2, I is 1, j is 3. So all the entries having their position which gives this condition, that is ith place is less than equal to jth place. Okay, so you can see over here, so this is called as upper triangular matrix, since because all the elements including diagonal and the above of this diagonal are non-zero, and this entries are equal to 0. This is the example of it. You can see all the elements including diagonal and above the diagonal are non-zero, and below this diagonal all three entries are 0. And again here I am taking here square matrix. Why square matrix? Because when you talk about square matrix, your diagonal is defined properly. You can see here above there are 3 elements, below also there are 3 elements. Now lower triangular matrix, again it is just the opposite of your upper triangular matrix. So here see, above your diagonal all the entries are 0, and here the diagonal and below this diagonal all the entries are non-zero. If you look at this here, you can see here Aij is not equal to 0 when I is greater than equal to j, and Aij is equal to 0 when I is less than j. You can see this example here. You can see all these entries below diagonal is satisfying the same condition. Ith place is greater than jth place. You can see here 3 is greater than 1. Here 3 is greater than 2, and including diagonal. So I is equal to j. So you say here 1 1 also included, 2 2 also included, 3 3 also included, and hence you get a square matrix of order 3. Let's go to the next concept, equality of two matrices. Now here two matrices A, that is Aij, here you can see the order is m cross n, and matrix B, the elements Bij, the order is m cross n, are said to be equal if they satisfies these two following conditions. So here they are of same order. So both matrices what you consider, both matrices supposed to be of same order. Next, each element of matrix A is equal to the corresponding elements of matrix B. What does it mean? Now look at this over here. Aij is equal to Bij. So in particular, if you consider, if you say here A11, it's supposed to be equal to B11. If you consider A21, then it's supposed to be equal to B21. Look at this now here. Example. Now here see, what two conditions supposed to satisfy here? They has to be of same order. You can see 2 cross 3, 2 cross 3. So I am saying these two matrices are equal. So I say 2 equals A11. This equal to sign signifies what? What is the value of A11? 2. What is the value of A12? 1. What is the value of A13? Minus 1, and so on. Now look at this here. Now again it is column matrix. This is also column matrix. Look at the order, same, and this equal to sign tells you B11 is equal to 3, B21 is equal to 2, and B31 is equal to 0. Now look at the problem. Now on this concept you can get many questions, and these questions are very important in exam point of view. Now look at this problem. Find values of x, y, z, a, b, c if these two matrices are equal, which is given to you. Now look at this. Now here see, x plus 3 is equal to 0. Why I can say that? Because the second condition tells you the corresponding elements supposed to be equal. Now look at this here. I get the equation x plus 3 equal to 0. So I write here, which gives me answer x equal to minus 3. Let's go to the second position. It is 1, 2 position. So z plus 4 is equal to what? 6. Look at this. Z plus 4 is equal to 6. So which gives me answer z equal to 2. And when I proceed further, look at this. Here you are getting here see, 2y minus 7 is equal to 3y minus 2. So you get equation in the form of y. So when I solve it further, I get y is equal to minus 5. Let's go for the next. I see I got value of x, y and z, and now I am proceeding further. Now look at this here. Minus 6 is equal to minus 6, look, right? So they are equal matrices, okay? So here see a minus 1 equal to minus 3. Look at this, I am writing this equation. From here I am getting the answer as a is equal to minus 2. Let's proceed further. Here see, 0 is equal to 0. So when I proceed further, I am getting things in that way, okay? So here 2c plus 2 is equal to 0. So I am getting here 2c is equal to, here see, 2c plus 2 is equal to 0, and I am getting c is equal to minus 2, and goes on, minus 1. And here see b minus 3 is equal to, you are getting as, here see 2b plus 4. So I am writing that equilibrium, and I am getting b is equal to minus 7 as answer. Now practice problems. Here you can pause screen and you can take practice problems and practice as many problems you can. Here I gave you all 3 such kind of problems, and the answers are also provided over here with green with red color, okay? So the problem number 1, 2 and 3 of similar kind. So see that you solve it as practice problem. Let's proceed further. Operation on matrices. Now when you talk about operation on matrices, there are different rules, there are different procedures or protocols we need to follow, and let us start with the first operation, that is addition of matrices. Now when you talk about addition of matrices, here see I take matrix A. matrix C, you can see the order of the first matrix is equal to order of second matrix. This is very important criteria. When you add two matrices, the order has to be same. Okay, otherwise the addition is not possible. Okay, so what we get over here, A plus C equals, you can see the corresponding elements are getting added. So what is the procedure what you need to follow? The corresponding elements you need to add. Look at this here, see, in general how we write, here see. This is the first matrix plus second matrix, and the first entry over here in the final output of addition, I am getting it as A11 plus, here see, C11. So this is my one entry at what position? A11 position. Let's proceed further for the second. So when you talk about here, see, what position is this? This position is A12, and what answer we are getting? Look at this, A12 plus C12. Look at this. So similar way, we add all the corresponding entries to get our final output of A plus C. Okay, same way when you go for the subtraction of two matrices, again I take matrix A and matrix C, and what I am doing, I am subtracting. Again similar protocol you need to follow over here. The order of these two matrices supposed to be equal. If the order is not equal, you will not able to subtract these two matrices, or you cannot find the difference of these two matrices. Again here see, the corresponding entries are getting added. You can see here A11 minus C11, again here A12 minus C12, and when you go further you are getting all the corresponding entries of the final output of matrix A minus matrix C. This is also called as difference of two matrices. So let's proceed further with the properties of matrix addition. So we have different properties of matrix addition. Look at this here. When you add two matrices, A plus B is equal to B plus A. It is also called as commutative property. This property is very familiar to you all. We studied this in real numbers as a first entry. Then afterwards we go to the second property, that is associative property. Now here what happens, look at this here, A plus B plus C. When you get answer, it is equal to A plus B plus C. So if you look at this, the brackets are arranged in different manner. So even if then the answers what you get are equal. So again the associative property is true. Let's proceed further. Next, existence of additive identity. And here you can see, when you say additive identity, here O. Now O is what? Your O is your null matrix. So when you add a null matrix to the given matrix, what answer you get? That is your matrix A. Okay, so over here you get O as matrix here, that is additive identity. We proceed further. Now here see, when you add A with the negative of the same matrix, what you get? Answer as zero matrix or a null matrix. Similar way, if you interchange their places also, you will get the zero matrix as your output, and this is called as existence of additive inverse. Okay, and over here minus A or negative of A is called as additive inverse. If you look at this example, you can see here matrix A, matrix B, and what I have to do is I have to add and I have to subtract. So when I add two matrices, here I am getting, see, first entry and the corresponding entry I must add. So 5 minus 5 plus 2 I am getting is as minus 3. Same way if I talk about this entry, that is A22. Look at this, A22 plus 8B22. So what I am getting, 0 plus 10. So what I am getting here again as 10. If you look at this entry, now this entry is 5. Here see how I am getting this 5. You can see this is 2 plus 3, that is equal to 5. Let's proceed further. Here see same way I will be getting remaining entries also. Now let's proceed further. Let us see how we get the difference between two matrices. Now over here look at this. This is matrix A, this is matrix B. I am finding their difference. So over here you see minus 5 minus 2. You are getting as minus 7 as output. Next, look at this. Let me talk about here, see, A31. Look at this here. I am getting here B31. So 2 minus of minus 2 I am getting as 4. Let's proceed further. Let us take this entry. This entry is what? It is A13. So A13 plus B13 I am getting it as 2, but when you talk about A13 minus B13, that is minus 3 minus 5, I am getting it as minus 8. So basically we follow the similar protocol over here when we add or when we subtract two matrices. Let's proceed further for the multiplication of matrices. Now when you talk about multiplication of matrices, there are two kind of multiplication. First, here when you multiply matrix by scalar. So here what happens, you have matrix A with you with the order m cross n, and what you do, you take one scalar. That scalar can be any number. That number you multiply to the matrix A. What happens? This K, this scalar goes to each entry and gets multiplied. You can see here this K goes inside to each entry and gets multiplied. Now look at this here. Example. I have this matrix A. This order of this matrix is what? It is, here see it has 2 rows and 3 columns. So the order is 2 cross 3. So over here see, here when you talk about multiplication of matrix by scalar, you can have matrix of any order. There is no restriction. But when you talk about addition, subtraction, both matrices supposed to be of same order. Now over here see, this K constant is multiplied to this matrix A. So this K will go to each entry. Look at this. Here see, KA, KB, KC, KD, KE, KF. So like this, this scalar gets multiplied to the given matrix. Now we have another concept called negative of matrix. So basically when you talk about negative of matrix, it is just the negative elements of the given matrix what you have, you represent it in the another form, that is here minus A. So when you talk about negative of a matrix, it is nothing but, here see, minus A, we denote it as minus A, and this negative sign. So negative 1, that you place in place of K, and how you multiply this K inside this matrix, same way this negative 1 will go and multiply to each element inside this matrix. Again the order can be of any form. It can be 2 by 3, it can be 3 by 2, it can be square matrix, it can be column matrix, it can be any matrix. Now look at the example over here. See, I have matrix A, similar matrix what I considered over here, and I am finding the negative of a matrix. So negative 1 I am multiplying in place of K here. Okay, so what happens? Here see, all the elements are negative elements over here. Fine. So let's proceed further. Let us talk about examples here. I take this problem. These kind of problems are very important problems in exam point of view. Look at this matrix A is given, matrix B is given. I need to find matrix as X such that AX plus 2A plus 3X equal to 5B. So this equation is given to me. What I do? First I take this equation, and how we solve it. You know, usually same way I solve to get value of X. Look at this equation I solve to get value of X, and what I get? X equal to, look at this, usual way, like you know, you see 2A goes this side, becomes negative. So I am getting 5B minus 2A, and the 3 which is here goes down. So you get it as 1 by 3. Now once I get this equation as X equal to, what I do? I substitute matrices in place of A and B. Now look at this here, what matrix B I have? That's this here, see. The same matrix I substitute. What matrix A I have? That's this. I substitute over here, and then afterwards you can see here this 2 is multiplied. So scalar multiplication I supposed to do. 5 is multiplied, again this here scalar multiplication. So 5 will go to each entry and will get multiplied. See, 5 into 2, that's 10. 5 into minus 2, that's minus 10, and goes on. Same way over here, 2, not minus 2. 2 I am multiplying inside. So 2 into 8, 16. 2 into 0, 0. 2 into 4, 8. Now here see, I have one matrix minus another matrix, both of them of same order. So the matrix I can subtract. So when I subtract corresponding entries, I am getting this 10 minus 16, I am getting minus 60. Again I am saying minus 10 minus 0, I am getting minus 10, and similar way I get remaining entries. Now here see, again the constant here which is out need to multiply inside. Again what multiplication I am doing? Scalar multiplication. So I get X equal to this 1 by 3 will get multiplied. So minus 6 upon 3, you get it as minus 2. Same way here see, you are getting minus 10 upon 3, so it is not divisible, so it remains as it is. Here see, you get 12 upon 3, so it is divisible, you get it as 4, and hence further you get similar entries later on. The next problem, again here see, I have if A equals matrix given here such that 2A plus 3B equal to 5I, find matrix B. See now over here see, I have matrix A, yes given. I need to find matrix B, okay, I need to find it, but I have here I have here I. Now what does it mean? Now what matrix I must take over here? This I signifies identity matrix. Now identity matrix of what order? You can look at this matrix. Now this matrix of what order you have? Order 2. So I take the identity matrix of order 2 into consideration, okay. So similar way how we did it in the previous problem, I solve this equation to get B equal to. Why B equal to? Because I need to find matrix B. So I am here see, I am getting here 3B I keep as it is, 2A I shift on this side, I get minus 2A. Then afterwards here B equals, I get it as here 5I minus 2A into 1 by 3. So I as identity matrix of order 2 I substitute. A, the matrix is given, I substitute matrices over here, and 5 gets multiplied inside identity matrix to get my scalar matrix. You can see the diagonal elements are equal and constant. So I get scalar matrix of order 2. Now here 2 gets multiplied, so I get this matrix minus this matrix. So when I subtract, here see 5 minus 2 I get it as 3. Again here see 0 minus 4 I am getting as 4. Similar way I get these 2 entries, and now again the final scalar multiplication I supposed to do. So I get over here as, here see 1 by 3 gets multiplied. to the corresponding entries here. So I am getting here as, you see, 1 by 3 into 3, so I get as 1. Minus 4 upon 3, so these are not divisible, so it remains as it is. 6 upon 3, I get it as 2. Minus 3 upon 3, I am getting it as minus 1. So this is how you get the answer. Now what point you need to note down? See, this 5i is a scalar matrix with the diagonal element as 5. Okay, which is extra what we are taking of the same order what you have of our matrix A. Okay, the next problem. Here see, when you talk about next problem, now look at this. The data which is given to me, that data is in equation form. Look at this, 2a plus 3b equals to one matrix and 3a minus 2b equal to another matrix. What I need to do? I need to find matrix A and matrix B. Usually how you solve your equations to get value of x and value of y, same way I will be solving. See, equation 1, equation 2. How we solve equations using elimination method, same way I will be solving here. Look at this. Here see, I want to cancel this. So b I need to cancel, so I multiply 2 here, I multiply 3 here. So when I multiply 2, this 2 gets multiplied to the entire equation, 3 gets multiplied to the entire equation, and I get these 2 new equations over here. What happens? Now okay, here see, so plus 6 will get cancelled with the minus 6, and I am getting here 4a plus 9a, that is 13a. Now look at this. This matrix plus this matrix. How you do matrix addition? Same way you need to add these two matrices. Look at this. Minus 2 plus 15, I am getting it as 13. 18 plus minus 18, I am getting it as 0. Minus 2 plus minus 24, I am getting it as minus 26. So like that, similar way I will get these entries, and I am getting here as 13a equal to this matrix. What to do further? Remember, I need to get matrix A. So A equals, this 13 will come down. So 1 by 13 into the matrix what I get, and this 1 by 13 will get multiplied to each entry present inside this matrix, and I will get matrix A. Right now I got matrix A. Let's proceed further to get matrix B. I considered my equation 1. Here see, this equation 1 I considered over here. So this equation 1 I take, in that wherever there is matrix A, I will substitute the matrix which I have got just now, and here see, I am getting here see it's 2a. So A I am what I got, that I substitute here. This 2, not minus 2. 2 you multiply inside. So when you multiply 2 inside, you get this output. So again, you need to find difference here of these two matrices, and when you proceed further, you can see here you get 3b equal to this matrix. Remember, I am interested in matrix B, not 3b. So what I get? Matrix B equals 1 by 3 into this matrix. Again, it is pure scalar multiplication. So what happens? This 1 by 3 will go and multiply to each entry present in this matrix, and I get the output as this, matrix B. So here I got my matrix A, I found my matrix B, and this is how this problem ends. Now here you have practice problems. Look at these practice problems. There are 5 practice problems which are given with their answers. You can pause this video and you can take this question and solve it for more perfection.
Prudent Scholars, powered by Lupin Pharmaceuticals.